Hi everyone, I'll be presenting on the assignment presentation problem given in this Excel file. Over on the left in question 1, we have a quadratic function of x squared plus bx plus c, where b and c can be input by the user. Let's take b equals to 8 and c equals to 5. As you can see in the yellow boxes, starting with C12, I've keyed in the formula of relative B12 plus absolute F4 times relative A12 plus absolute H4 and drag the column of C12 down to C22, thus giving the values for the rest of the yellow highlighted cells. For question 2, in order to get this graph, I just copied this entire table and went to insert and put the charts. Y equals x squared represents a basic quadratic function and is a parabola that opens upwards symmetric around the y-axis and it passes through the origin 0, 0. While y equals x squared plus bx plus c can be shifted either vertically or horizontally. For a horizontal shift, the graph shifts left when b is positive and right when b is negative. The amount of shift depends on the magnitude of b. For a vertical shift, the graph shifts upwards when c is positive and down when c is negative. Similarly, the amount of shift is dependent on the magnitude. For question 3, I have to find the numerical discriminant through various b and c inputs. The discriminant is used to determine the nature of the roots since this is a quadratic equation of y equals x squared plus bx plus c. The discriminant is key in is f4 squared minus 4 times 1 times h4 with a equals to 1. For determining the solutions of the equation, the formula of x equals minus b plus minus square root of the discriminant divided by 2a is derived. For question 4, so given the completed square form, we can relate it to the basic form graph y equals x squared by considering the effect of parameters b and c on the transformation. Firstly, note that x plus b divided by 2 square shifts the graph horizontally. Specifically, if it shifts the graph b divided by 2 units to the left if b is positive and b divided by 2 units to the right if b is negative. The term c minus b squared divided by 4 adjusts the vertical position of the graph. If c minus b squared divided by 4 is positive, the graph shifts upwards, and if it's negative, the graph shifts downwards. The amount of shift is determined by the value of c minus b squared divided by 4. So, in conclusion, as compared to the basic graph of y equals x squared, the graph y equals x squared plus 3x plus c is moved vertically by c minus b squared divided by 4 units and horizontally by b divided by 2 units. The values of b and c determine the shift direction and magnitude change. For question 5, we know that the discriminant determines the nature and number of solutions of a quadratic equation. But how? Firstly, when the discriminant is more than 0, it means that the quadratic equation has 2 distinct real roots. This can be seen as the graph intersects the x-axis at 2 distinct points. Secondly, when the discriminant is equals to 0, this means that the quadratic equation has exactly 1 real root, and this can be seen as the graph touches the x-axis at only 1 point. Lastly, when the discriminant is less than 0, this means that the quadratic equation has no real roots. In other words, the solutions are complex. This can be seen as the graph does not intersect the x-axis at all. So that is the end of my presentation. Thank you.